So when we do aldol condensation versus aldol reaction, condensation actually means that you're losing a molecule, and the molecule that you generally lose in condensation is going to be water. Condensation means losing a small molecule, HCl, CO2, H2O, something like that. So here we're going to be losing water in aldol condensation. So which means that if there is dehydration going on, dehydration of alcohols give us alkenes. Okay, so already when we look at the problem, we're like, oh, okay, I gotta form an alkene. All right, okay, so we're supposed to give the mechanism and products for aldol condensation for 3-methyl butanol, okay, and using sodium hydroxide. Now sodium hydroxide is just a base. We could use any other base also, sodium methoxide or ethoxide, LDA, whatever it is. So in any case, let's get started. So we have 3-methyl butanol. So here is butanol, 1, 2, 3. Here is the methyl group. Okay, and so the first step, of course, is going to be sodium hydroxide picking up the acidic proton, the alpha proton, which is right here. And so then we end up getting the nucleophile. All right, so the nucleophile now will attack the electrophile, and the electrophile is another molecule of the aldehyde or ketone. It could be, but in this case we have only one compound given to us, so we'll just work with that. So again, remember, this carbon is the one that's the positive, and that's the electrophile. Okay, and so here we go. That's the reaction that happens. And again, if you remember me saying this before, is that it's really important for us to be right rather than to be pretty. Okay, so let us go ahead and be right here and not pretty yet. We'll be pretty eventually, maybe. So then here, this is the fragment that we have on top of the arrow, and then the bond that's forming is going to be on this carbon and this carbon, right? So that carbon right there has the aldehyde, and then it has the isopropyl group coming out of it. Okay, I know it looks awkward, but that's fine. Okay, it's much more important to make sure that you don't lose any carbons in the process. Okay, so then the next step is going to be the protonation of the oxide, and so here we go. And we'll just keep it like this for a bit, and then we'll see when we need to make it pretty. Okay, so there is that. I think I lost a carbon already, didn't I? Yeah, I did. Okay, so here we go. I think this is how it's going to be right here. Yeah, you probably already saw that. It happens a lot in aldols. I don't know, for me also, I just have to make sure I remember to put all my carbons intact. Okay, so in any case, that's what we have. So now here, I'm coming back here now, and here is the CHO, and you can write CHO. You don't have to write it like I'm writing it. Okay, it's entirely up to you. And then here is the isopropyl group attached to this carbon. So now we're doing good. Okay, so now for the condensation part is where you actually get the hydroxide. And when you are forming an alkene, you have to remember that we will still follow Zaitseve's rule. Okay, so Zaitseve's rule was that you're going to form the more substituted alkene. All right, so in this case, it doesn't really matter whether you form the alkene here or you form the alkene here. Remember, this is the OH that has to go away. So either you take this proton or you take this proton. It doesn't matter. And in this case, maybe you end up getting 2 alkenes, but we're just going to focus on one, okay, over here. So again, since we have the hydroxide, we are going to go ahead and pick up a proton, and we'll just go ahead for this one because this seems a little bit more acidic than usual. So we'll pick up this proton. This proton then leaves, and this alcohol leaves. Okay, from here, that's the dehydration that's going on when we do this this part. So then let's go ahead and write our compound that we have. The OH is gone, okay, at this point. So then we have the alkene right there. We have the CHO. Yeah, fine, I'll write it as CHO as well. be easier. And then you have these two. Okay, so this double bond, I know now this one is looking really awkward. Okay, so we're gonna have to redraw that one, but this is the product, okay, that you end up forming. So let's go ahead and rewrite that in a nice way. And the CHO now is in the middle. It's not like it's, you know, in the at the end somewhere, because, you know, the way the compound was. So in any case, let's go ahead and write out our longest chain. So 1 2 3 4 5 6 7 8. Okay, so we have 8 carbons here. So 2 3 4 5 6 7 8. All right, so if this is the 8th carbon, on the 7th one I have a methyl. This is 6, this is 5. 5 and 4 have a double bond in there. 4 also has a CHO coming out of it. 3 2 2 has a methyl group, okay, out of there. So that is your compound, and this one looks, you know, just a little bit prettier than before. So for your sanity, if you need to go ahead and, you know, write this out in a pretty way, you can do this. This is fine as well. Okay, it's just that it does look a little awkward. Maybe it'll look a little less awkward if you remove the hydrogen, this one. But anyhow, so that's aldol condensation.